Hey, in this video and the ones that follow it, we'll be learning to write nuclear equations. And in order to do that, we're going to need to learn to write nuclide notation, and then we're also going to learn about some of the different forms of radioactivity. This is nuclide notation. We'll use it in nuclear reactions. It's different than chemical notation. You have to tell a little more information about an element. And so the nuclide notation looks like this. This is the symbol for an element. I've used X because there is no element X. And you have to put two pieces of information on for nuclide. Now, the word nuclide comes from the same root as nuclear, and what it's telling us is the information about the nucleus itself. We're not going to care too much about electrons in this. In fact, electrons have a special name here. We'll get to that in a second. But this is the element. Symbol represents the nucleus of the element. And then down here on the left side, or the front side, before the element symbol, we're going to write the atomic number. That's the number of protons. Some people would say it's called the nuclear charge. It's the charge on the nucleus, and we'll see why that distinction needs to be made in a minute. We write that to the front and slightly below the line, and then the mass number of the element, and remember that's what tells us which isotope it is. The mass number of the element goes to the left, also above the line for the by the symbol. So those two pieces of information, and they tell us what we need to know about this nucleus of this element X. All right, so let's do a couple of examples. So I'm going to go to the board here. These examples then are going to be a couple of relatively common nuclear or radioactive elements. Let's start with carbon-14. So if we're going to write the nuclide symbol for carbon-14, we write the symbol for carbon, which is C, and then we are going to write in the position that is in front of but below the atomic number for carbon. So you're going to have to go to a periodic table or an alphabetic list and find that carbon is number 6. It has 6 protons in its nucleus. And then here's one of the things that's simple about this. The mass number, which is the number of protons plus the number of neutrons, you don't have to figure it. It's right here. It's given in the notation. This tells me it's carbon with a mass number of 14, so I write that right there, and that's all there is to that. Okay, so for uranium, we do exactly the same thing. Uranium symbol is U. It is number 92. You can look that up. And then for the number above, again, right there it is, 238. Now you are going to have to memorize a few things, and here's one of them, an alpha particle. Okay? An alpha particle doesn't give you the information you need about what it is. You have to just memorize that an alpha particle is equivalent to a helium nucleus. Okay, so that's the name for a helium nucleus when we're talking about nuclear particles. It's called an alpha particle. It's called alpha because it was the first one that was discovered. An alpha particle, helium nucleus, has 2 protons in it, so its atomic number is 2, and it has 2 neutrons, giving it a total of 4. So this is always the symbol for an alpha particle. Right, and here's why that's important, because as we go forward here, we're going to learn about these different kinds of substances which undergo nuclear changes. These are unstable nuclei, we'll look at it in a minute. Alpha particles, we just saw one of those. Beta particles, gamma radiation, positron emission, and electron capture. So in the next couple of videos, we'll be looking at examples of each one of those.